Now we're going to discuss randomized complete block design with more than one missing value. We have already discussed CR RCBD model with one missing value. Here we are going to discuss how to handle a model RCBD model with more than one missing value. Yes, here you are having a complete case. So finally, at the end of this discussion, you can compare your adjusted data calculations with the original data set. Now you can see I have used the similar data set in here, but here there are no any missing data, but here you can see there are two missing points. Then Y22, the place of Y22 and Y41 have missed here. Then we can estimate those things by using this equation as we have used in the previous case. Then we have taken the average of this column and the average of this row and add up those two together and divided by 2. Then finally we have a value for the Y22. By using that method for Y41 also we can have an observation. Now after completing that column, again we have to make an estimation for the Y22. Then again we are taking the value for this case and values for this case. Now you can see some difference. For calculating the first observation in first time, we have taken the column total and row total and we divided it by 2 and have a value. But here we have used the equation we discussed early time, but we need the grand total here. So by subtracting that value into G, then how we have calculated this grand total with the estimated value in first time. Then we have used the estimated value for the Y22 to have this grand total here. Then we have used that grand total in here and we arrange this equation and have this value. Then again, we have to use this equation into the calculations of Y22 because we did not apply the grand total at first time there. So by using the previous estimated value, we can add up all observations and we can have the grand total again by removing the first estimated value for the Y22 and we can make the estimations for the Y22 again. So this is the value we can apply for this one. And again we can do estimations for these things. Then we will have some different values. So first time we had 4.15 for the Y41. Then after making these adjustments for the, after including second estimation for the Y22, we will have somewhat different value for the Y41 either. So we can do this step again and again, but after giving this value, we are having again the same value as the second estimation for the Y22 calculation. So then after having some similar values, we can stop the calculations, but we can keep our calculations again and again until we have a suitable solution. Then you keep going through these steps until the estimated values don't change. For this problem, I would probably estimate Y41 one more time. Calculations of least square estimations designed, I will discuss those things later. When this is with missing value is not similar to the used when there is a missing value. So anyway, this is the final calculated ANOVA table for this missing case. So the error term is somewhat different in here because the first time in the complete case, we have altogether 12 observations, but after missing 2 observations, we have only 10 observations in our original case. So 10 minus 1, there is total degrees of freedom is 9. Then after removing treatment and replication degrees of freedom remain, there are 4 degrees of freedom for the error. So this is a completed calculated table for the missing case. Then you can compare these answers with the original case either, and you can draw your conclusions. Then about the mean separation procedure, I will talk about that later after completing that topic.